Today we will be talking about special cases of absolute value equations. So the first kind of special case you might see is an absolute value equation that has no solution. So sometimes when you're solving the absolute value, you will end up with no solution. Remember, absolute value means the distance from zero, and therefore it will always equal a positive number. Distance can never be negative. So here's an example where that may happen. Starts out like any other equation. Solve the following equation. -3 times the absolute value of x minus 4 equals 12. The first step is always to isolate the absolute value. So we would divide both sides by 3. And when I do that, I have the absolute value of x minus 4 equals -4. My absolute value is isolated. Now, when I look at this, I need to think, what does that mean? Well, that means the distance from zero, the absolute value, equals -4 spaces. That's not possible. You cannot have a negative distance. So therefore, there is no value of x that will make this equation true. So it has no solution. So if you isolate your absolute value and it equals a negative number, there will never be a solution. It will never be true. Moving along to the second special case you might see, and that's when you're solving an equation with variables on both sides. Sometimes when you solve an absolute value with variables on both sides, you will get something called an extraneous solution. What that means is a solution that you got numerically, but when you check your answers, it does not actually make the original equation true. So it's very, very, very important that you always check your answers to determine if your solutions are valid or extraneous. So every time you solve an absolute value equation, you must always check your solutions to make sure that they are valid. So here's an example. Solve the following equation, and note it says be sure to check for extraneous solutions. So I've got the absolute value of x minus 4 equals 2x plus 7. The absolute value is already isolated in this case, so we can move on to second step, which is to separate your equation into two. The first one, remember, you always rewrite what's inside the absolute value. You never change that part. You just drop the absolute value bars, equals what it already equaled in the original problem. For the second equation, again, you rewrite what's in the absolute value bars and drop the bars, but you change the signs on the other one. Note, you must change all signs when you're making this equation. So it originally was 2x plus 7. Now it's -2x minus 7. I changed both signs. After you've separated it into two equations, then you can solve both of those equations. So solving the first one, I need to get all my variables to one side, so I decided to subtract x. When I did that, I got -4 equals x plus 7. Then I need to solve for x, so I subtract 7. And my first solution is x is -11. Solving the second one, again, I'm going to get all variables to one side. For this one, I added 2x to both sides. That left me with 3x minus 4 equals -7. Then I add 4 to both sides. And when I do that, I get 3x equals -3. Solve that, divide by 3. And I end up with my second solution, which is x equals -1. So far, this problem looks very much like the other types of absolute value equations we've worked through. But remember, we must always, always, always check our solutions. So let's go do that. There's my original problem again. The first solution I got was -11. So I substitute -11 in everywhere I see an x in the original problem and solve it. Well, notice when I do that, -11 minus 4 is -15, but the absolute value of -15 is +15. The other side, 2 times -11 is -22, plus 7 is -15. Well, 15 does not equal -15. That means this is called an extraneous solution. That means x equals -11 is not actually a solution to the original absolute value equation. It's extraneous. It is not actually a solution. Now I'm going to check x equals -1. When I substitute -1 into the equation, I can solve it. -1 minus 4 is -5. The absolute value of -5 is 5. 2 times -1 is -2, plus 7 is +5. +5 does equal +5. So therefore, x equals -1 is a solution to the original absolute value equation. So in this case, when I did the work, I ended up with 2 solutions. When I checked my answer, one of those 2 solutions was extraneous, meaning it is not actually a solution. Therefore, the final answer for this problem is x equals -1. That is the only solution. So this absolute value equation ended up having only one solution. Sometimes when you check your solutions, neither of the solutions you got are true for when you check them. In that case, your solution would be the first special case, which is no solution. So it is possible to have 2 solutions, 1 solution, or no solution when solving absolute value equations. So the moral of the story is always check your solutions when you're solving absolute value equations.